Welcome to the Academic Digest class. Today we are going to be treating integrated rate law, third order. We know that rates is directly proportional to concentration. Let's say here is C. It is directly proportional to concentration. And introducing proportionality constant becomes Kc. Then for third order is when the power is 3. Just like quadratic equation, when the order is 2, we say it's quadratic equation. When it's 3, we say cubic and hertz, the third order. So if I know this, what this means is that we need to remember that rate of reaction is directly proportional to the disappearance of the concentration at a given time, or let's say over time. So rate of reaction is equals to Rate's law, which is K. So if I know this, I will need to make this in such a way that I'm trying to get this to be here. I'm trying to make concentration subject of the formula. So if you do this, it will simply become such that I have minus D, or should I say change in concentration is equals to constant C raised to power 3 then times dt. At this point I can divide both sides by the order C raised to power 3, and if I do that I will have this will take care of this, so that I'm now left with K change in T is equals to this negative sign. I want it to cross equality sign. It can cross, you can say divide both sides by minus, and whatever we do, this one will get out. So move here, so I have D. Whenever I'm making this video, pardon, there's so much air inside the room, so alright, so all over so if I introduce integration sign, now I've been able to get what I want. So now I need to integrate. So if I introduce the integration sign, it is going to be such that it is not a definite should I say, it's not an indefinite integral, it's a definite one, such that I have the boundaries is such that we move from 0 to time, to given time. So if I know this, the same thing applicable here, so that at the end of the day, this will now be the same thing as saying integral of T0 then 1 over C concentration raised to power 3 with respect to this D C means with respect to change in concentration is equals to, in integral I'm allowed to pull out the constant, so this becomes T0 change in T. And you know that if this is change, it is the same thing as saying multiply by 1, it will still give you the same thing. So you need to know that if I integrate this, let me do it one side. If I integrate 1 over C raised to power 3, 1 over C raised to power 3 is the same thing as saying concentration raised to power minus 3. And by integral, we add 1 to it, then divide by the power. That's integration for you. So this is going to give me C raised to power minus 2 all over minus 2. And this is the same thing as saying 1 over minus 2, then C raised to power minus 2. And this right here is the same thing as saying 1 over C raised to power 2 times 1 over minus 2. If you remember indices, so this is the same thing as saying 1 over 2 minus 2 c raised to power 2. So this is what I'm going to carry and put here. So if you integrate, this is what you're having. This is integration. Don't look at this side though. This is work that I've done earlier. So this is what you have for the integral. So let me carry it and put here. So that means I will now have 1 over minus 2c raised to power 2. And this becomes, once you integrate, you just show the boundary t to 0 to t. The boundary is such that this thing means boundary from 0 to t, a straight line, equals to, if you integrate this, is just minus k, come down, integrating 1 with respect to t, 1 times t, so it becomes t. So you put the boundary, since it's 0 to t, you still put the boundary 0 to t. So this is going to now give me the same thing. Interpreting what this boundary means simply means I will have to get okay, there's minus here, let the minuses cancel out. So I have 1 over 2c square at t minus 1 over 2 concentration of c square initial, this 0 means initial, equals to kt at t minus t at 0. And you know that t at 0 is 0, so there's no use for this. It's not like concentration. Concentration of something initially can be 20 gram or something, but time at initial, at initial, when something starts, time for it starts from 0, and 0 time is 0. So we just have kt. So we can say that this is now the same thing as saying 1 over 2 concentration of c raised to power 2 square for t equals to kt. This one crossing over becomes plus 1 over 2 concentration of c, initial concentration of c raised to power 2. Now notice why I did it this way is such that what I have here can choose to represent y, and what I have here from line of equation, this can represent x. That is, if I'm doing concentration against time, then this one can represent m, the slope, and this one can represent intercepts. But notice that our goal is to always make the concentration at a particular time the subject of the formula, so we need to make it subject of the formula. So for that reason, I will use LCM to get a common denominator for this. Let me rewrite it. So if I rewrite this, I'll have 1 over 2 c square t is equals to kt plus 1 over 2 concentration of c square 0. Yes, yeah, I should be correct. So all over 1. So getting the LCM, I'll have 2 dies of this side. This divided by this is 1 times 1, 1. So if I know that equals to 1 over 2c square t, we need to make concentration when at a particular time subject of the formula. That's why we are solving further. So you see that this we can cross multiply, so that we now have 2 concentration, initial concentration square is equals to 2 c square t multiplied by 2 c square initial kt plus 1. So we can say, since we want to make this subject of the formula, we divide both sides by this. Remember that this is integrated rate law for third order reaction. In most universities you don't get to this point, but you have to do it, so you learn. No need is a waste. So you can see that at this point we are left with 2 initial concentration square all over 2 initial concentration square multiplied by Kt plus 1 is equals to 2 concentration square at time t. So anything standing on this one is over 1. We can say there is 2 here, there is 2 here, 2 cancel 2. Whichever way you want to do it. If you do 2 over 2, that means you have to divide by this 2 at the end of this. So it's better you do this and this. So we can see that this square here, we can eliminate this square by saying take the square root of both sides. So I have c square all over 2 concentration square Kt plus 1 is equals to square root of c concentration at time. So this will get rid of this. For this particular one, notice that this is the sentence saying square root of this over square root of this. So this will get rid of this. So we are left with having only square root for this one. So this is now the sentence saying C, concentration of C at time t, which is what we are trying to do, is equals to initial concentration all over square root of 2 initial concentration square Kt plus 1. So that is my final answer. So I can write it this way. I can say for third order reaction, the integration is simply concentration at time t is equals to initial concentration all over 2 square root of 2 concentration initial concentration square Kt plus 1. That's your final answer. Remember that this is square. So there you have it. So please remember to like, subscribe and share.